All right, we are going to solve frequency queries. So, you're given Q queries. Each query is of the form 2 integers described below. 1. Insert X into your data structure. Delete one occurrence of Y from your data structure, if present. And Z. Check if any integer is present whose frequency is exactly Z. If yes, print 1, else print 2. Okay. The queries are given in the form of a 2D array. Queries, where Q queries 0 contains the operation. 1 contains the element. For example, if you get this, the result of each operation, the results of each operation are, the hell is this even asking? So, you're given queries. Each query is 2 integers. Got it. The result of each operation. X, Y, and Z. I don't understand where X, Y, and Z come from. Each query is in the form of 2 integers. Described below. Insert X into your data structure. So each query, the first is the operation. Oh. I got it. Okay, so these are the enumerated operations. So 1 is insert X into your data structure. 2 is delete the occurrence, one occurrence of Y from your data structure. 3, like this one, check if any integer is present whose frequency is exactly Z. Okay. So this is saying, this query here is saying, excuse me, insert 1 into your data structure. This is saying delete one occurrence of 2 if it's present. This is saying check if there's any integer whose frequency is exactly 2. And if so, print 1, otherwise print 0. Okay. So, operation. 1, insert this value into your data structure. Got it. 2, delete one of these if delete one instance of 2 if present. Done. Check if any integer is present. Well, an integer 2 whose frequency is exactly Z. Oh no, that's the frequency. So check if there are any who are if there are 2 instances of any integer. Print 1 or 0. All right, now insert 1, got it. Insert 1, got it. Delete one instance of 1, got it. Are there any integers who have exactly 2 instances? Yes, 1. Okay, got it. Return an array with the output 0, 1. Presumably, that's the different stuff that I output. This array here is, my data structure is just an internal state that I'm going to keep track of. What we actually want as a result is my output, which will only be when I get an operation 3. So, complete this function in the editor below. Must return an array of integers where each element is 1 if there's one value and 0 if there's not. Got it. Got it. Constraints. Let's look at the problems we need to solve. Ugh. All right, I gotta see if we're looking at the right board here. Is that good? Oh wait, my personal notes here. So let's break this problem down into smaller problems. So get my way here, man. Oh. So insert. What I need to do is I need to loop through the queries and pick an operation to do. Okay, so I gotta be able to loop through this and pick an operation. These are going to be encoded, so I got an enum where it's like 1 insert, 2 delete, and 3 check frequency. Okay, that's not too bad. I'm going to have, what am I going to have to keep track of? I have to have an array here with my state of these different operations. And I'm going to have a result that will be populated every time operation 3 is called. So inserting a value is pretty straightforward. We'll just go ahead and push. Delete one occurrence. That's pretty easy. We're just going to find it and slice it out of there. Splice it out of there if it exists. Check for anything, any integer whose frequency is exactly z. Okay. So let's break these out a little bit. This is just going to be simple push. This one's going to be get the index, and if it's greater than -1, then splice it out of my state. Checking the frequency, check any integers present whose frequency is exactly z. How do we check the frequency of a value? That's a sort of a sub-problem that we'll have here. So if I have an array, which I do, I could just let's give me something to work with here. 3, 2, 100. So I have an array. I want to check the frequency. I would start here, the first guy. This is the value that I'm going to be checking. My current index is 0. I'm going to check and see if there is another index of v from 0, starting from the next index. If there is, I can just keep repeating that cycle. Let's see. Sort of like, I don't know. I don't know if I want to write an actual loop here. Let me think out loud here. So I'm going to loop through the array. First I'm going to pick a value, and then I'm going to keep track of the count of instances there. Well, I guess I'm going to initialize it with 1. I'm going to loop through the array, right? So value equals 3, index equals 0. Initialize a new count here, and I could say, I would have another loop within here. I would say sort of find the next index. That's going to be, array index of value starting from I plus 1. And as long as there is another index, then I'm going to increase my count and continue. So this will kind of blindly go through it and get us all of these counts. Now I need to find a way to break out of this when I found my answer. So this mechanism will allow us to go through and count the instances of each value, but that could be quite wasteful, because if we just want to know if there's anything that occurs twice, say, yeah, 1, 2, got it. I don't need to keep looping through all of that stuff. So since this exercise only wants us to know if there is something with X number of occurrences, has X, instances, right? Then it doesn't care what value it was. It doesn't care about any others. And we only want to see, let's see, that it has at least, check if any integer present whose frequency is exactly Z. So it's exactly not less than or not more than. So if we're looking for exactly 2 3s, this guy wouldn't work, or this guy would work, but here it would not. So we can't break out as soon as we find X number of instances in our account. We need to go all the way to the end, let this loop through for each instance of the particular value. Then, at the end of this loop, we would check, does it match X? If it does, we can go ahead and bail out of the whole thing with a true. Otherwise, we would sort of, probably force feed it, set an initial result as false, and I guess we could just return false, whatever. That's just syntax. So to revisit this, we're going to get a bunch of queries. We're going to loop through we're going to get a bunch of queries. We're going to initialize our state. We're going to initialize a result. This state is where we're going to be putting data and querying and all that sort of stuff. We're going to loop through our queries. We're going to look at each one and say it's a tuple. It says the first one decides what operation we do. If it's an insert, we're going to take the second value and we're going to push it into state. If it's a delete, we're going to find one instance of the second value, the second field in our state, and we're going to splice it out of there if we find it. And if we don't, whatever.
It's 13 hours.
And then if the operation is a 3, then we are going to check. We're going to take that second parameter and put it into this function with our state and say, hey, does this have n, whatever that second value, instances of one of these numbers? To determine that, we're going to loop through the thing, start at the beginning. For each value, we need to do not repeat. For each value, we're going to go in, initialize a count, find the value, and we're going to do an inner loop that finds the next and the next and the next of that same value. As we find those, we'll increment our count. after we've counted all of these up, don't forget this optimization here, we are going to say, hey, does this match the does this match the value we're querying for? If it does, true. Otherwise, carry on with the next one. Once it's gone through the entire list and has not broken out, we will know that we in fact do not have that value, and we will return false, which will be put into our result. And after all that's done, we'll return our result. Pretty straightforward. As I was talking here, I realized if we check something, like we're looking for something that has 5 instances, if we check 3, now that doesn't satisfy it. Then we go here, then we go here. Then we're here checking 3 again. We've already done that computation, so we need to take that into account. Let's leave that as an optimization though, because first I want to get something that we can ship. So I'm going to attempt to just write this happy code here. So, squatting is the proven way to be super productive. So, let's see. Let's go find our stuff. Line. Yeah. It's just kind of garbage. Okay. So, like I said, we are going to have a state. Let's we're going to use let because we're going to be goofing around with that state a lot. So we'll start there, and we're going to have const result. And at the end of this, we are going to return our result. I'm going to just put some stuff in here just to make sure that we're talking to the test harness correctly. Your output's here. Okay, good. We output this. It expected that. All good. Uh-oh. This is Jeremy. All right, I hope you remembered to go back in, edit out that private information. So this is real life coding. Just got interrupted by a phone call. What the hell were we doing? Oh yeah, we were confirming that our output was getting here, and it is. Cool. Now, let's do some implementation. So we're going to get these queries. We're going to loop through the queries and need to select which operation we're going to be doing. So let's do, queries for each. Let's go ahead and pop them out of here. And they're going to come in the form of, they're not going to come in that form. It's not a string, is it? Let's look here. What's my input? Okay. Each of my queries. Let's look at each query. Let's just keep it simple. Query equals console log query. Go ahead and save that and run it and get a look at what our queries are actually coming in as. Suspect it's an array. Come on, man. Oh, this system. Okay, here we go. Here's my in. Here's my out. Yeah, look at that. That's not what we got here. That's totally different. Well, I'm glad we checked. So we're going to get 1 is our operation, or the 0 is our operation, and 1 is the data we're going to work with. So let's do this. Just to be super explicit, we're going to say operation and the data element. Pull those out of the query. Operation and data. Now, we're going to go ahead and have some branching logic here, and depending on what our operation is, we're going to do different things. Let's go ahead and want to put an enum in here, but that's all right. We'll just do switch operation case 1. Just going to set these up so we can crank them out. I'm just going to do this as the default. This is going to be 1, 2, and 3. And this is getting a little bloaty already. So I'm going to call out to a different function here, so I can keep the logic small. So what we're going to do is console log, or what's number 1 called? Insert. We're going to do insert data. And here we're going to do delete, and not use delete. Let's just say remove data. And our default is going to be check frequency data. Now, obviously, I'm not passing it everything it needs. I'm just sort of setting up the framework for it. So const insert console log insert remove and check. Yeah, there we go. Check frequency. It's going to be check frequency. Now let's just look at this and see if we are talking to the right things. 1, insert. 3, check frequency. 2, remove. Okay, so we're branching off correctly. Let's handle these one at a time. Let's do insert. So we're going to get the data. Oh, we forgot our little accumulator here. Each one of these we're going to need our state, obviously. And we're going to be updating the state with these. Except for this guy, he's just doing a query. We'll get back to this. This is going to return a 1 or a 0 eventually, but one step at a time. So insert, we're going to pass state into data. So we're going to say this is our state, this is our data, and we are going to return state and data. I said I was going to push, but if I did that, push would return the new length. That's not what I want. This is a little bit nicer. After this is done, why don't we look at the state just to make sure that it's doing what we want. So I frequently stop and run my code. So the state is 5. The state is 5. Did I remove a console? I did. So let's kind of look at these. Saying 1, insert 5, 1, insert 6, insert 10, insert 10, insert 6. I'm not doing any of the other operations right now, so it's 5, 6, 10, 10, 6. That one looks like it's working swimmingly. Don't need to log that anymore. Now, for remove, let's handle that guy. Remember, we're going to take the state, we're going to take the data, we're going to do our magic, but we had a twist in this one. We were going to, I'm going to return the same state just for expediency. And it's a little dirty. I'm going to be actually manipulating this state directly, which I don't like, but that's okay. So what our logic said is we need to get the index of data within state, index of data, and if, and only if, index is greater than -1, we will remove it. So we can do state, splice, index, remove one of them. This is dirty, dirty, dirty. So it's actually going to manipulate the state up here. And when we return it, that value will be removed. So let's console log our state. Before we do that, I want to see sort of the before action too. So I want to say remove data. Let's run it and see if it works. So it says remove 5, and 5 is gone. This isn't a great feedback. It was there, now it's gone. Could probably add more logging, but remove this. It did. Well, it didn't even exist, but that's all right. Why is the state 0? That's all right. We don't want to get ahead of ourselves. So this state will have a 3, then we remove the 3. Right? Perfect. Yeah, this looks like it's working well. So, get rid of this logging stuff. And again, the reason we're doing these very small baby steps is to make sure they're solid. Because if we go too quick here, then we'll have a shaky foundation. So check frequency. This isn't going to be updating the state. This is going to be updating our results, which delete inner brackets, which is going to contain a 1 or a 0. So instead of updating the state, we're going to say result push whatever that is. So right now, it's not doing anything. State data. So it's funny because it's inside of this. Switch statement. So there's sort of like this implied suggestion that these are all the same, but it's doing a very different thing. And I think this makes it clearer that this has a different interface. I mean, it's taking the state and data, but it's serving a different purpose. It might be better to, if this were to expand and we had more operations, to split these out into sort of like operations that would update the state versus more just read-only. But for right now, this is fine. And again, we don't want to get bogged down with silliness. So there's remove, working well. Here's check frequency. Remember, we need to return something. So I want to just make sure that this is populating our results correctly. So I'm just going to return 9, which should stick out like a sore thumb. Processing, processing, processing. And the output was 9 and 9. So good, that's being fed in there correctly. So now we get back to our fun parts up here. Just this little sub problem, which is the interesting part. So for this, we're going to loop through the state. Right? Let's just start there. State for. No, I don't want to do for each because I do want the ability to bust out of this. So I'm going to do for let I equal 0, I less than state length, I plus plus. So my value that we're examining is state I. Console log the value. Let's start there. actually, before we do that, remember we were saying we're going to return false, not false, we're going to return a 0 or a 1. So here, return array with this. If yes, if we found a one that matches print 1, otherwise print 2. In this case, it's return 1 or 2. So I'm going to say let result equal no. And we are going to return the result. That's very pessimistic, but that's all right. It's better to be to say no, we did not find something until we prove that one exists, and then we can bust out, versus having to go through and prove for every instance that it's, I don't know, it just seems like being pessimistic in this scenario works better. So let's just look at this. We should now have 0, 0 being returned, and it should be telling us what each value in our state is. So let's look here. Add 5, add 6, remove 2, add 10, add 6, remove 5. Check for this. So at this point, 5, 6, 6, 10, 10, 6. I think that's right. Yeah. So, yeah, there we go. At the very end, it's looping through. And now, what are we going to do with this? We need to check. This is the outer loop of the state. We need to go and check for other instances in the state of this value. So to do that, we were going to start another loop. Or, well, first we were going to initialize our count to 1. And then we were going to start another loop for let j equals I plus 1, because we're going to start at the next place, while j is less than state length j plus plus, and that's convention ij. So here we are. Now, while we're looping through, let's keep talking here. So we're going to say we're looking for other instances of value. And I lied here. We need to be doing it based off next index instead of doing a loop. So, got a little bit ahead of myself. So what we can do, let's do a do while. So let next index, we're just going to initialize the next index up here. And we're going to say next index equals state index of next index, excuse me. I need to keep track of the index as we move through this, right? So let's keep this simple here. Let's just find the next index, and then we'll figure out how to loop there. Next index equals state index of value from this guy's index. Console log next index. And I want to see the state too. Let's check it out. So here, it's not very clear because I didn't say what we're actually looping through. The state is 5. The next index is the one I'm currently looking at, because we need to increment that. We don't want to look from where we currently are, right? So let's say value next index Now I just want to kind of go slowly through this part so I make sure I'm getting it correct, and then we can optimize it. So I'm at 5 currently here. The next index is -1 because there's no other 5. Let's look at this one. This is a little more interesting. So here, value 6, there is no other 6. All right. Here, value is 6. Next index is 3. Okay. I would like to find one where I could loop through multiple times. But doesn't look like we have one. That's okay. So what I want to do is we're going to need like a frame of reference for where the previous index was found, or where the previous instance was, and where the next one is. So index equals I initially, next index equals this index plus 1, and we could say do this while next index is greater than -1. Now, of course, this is very dangerous because we're going to have to increment this loop, or increment this, or we have to change the index, right? Otherwise, we're just going to keep spinning around in circles here. So, say, here's my next index. At the end of this, I would say, kind of move my pointer, so index equals next index. That'll move it along. So here is where we are inside of this loop to increment our count. And so we'll say if next index is greater than -1, count plus plus. Now this is the kind of stuff where I see this redundancy here, and I could just bust out of this at this point. I don't really need the while loop. I could just have it go through until we get to this point. But that's okay. The optimizations will come. This is rough draft stuff. So here I want to see the state, I want to see the value, and I want to see the count. So this will go through each time this function is run and sort of give us a tally. So the state is 5 and 6, value 5, I found one of those. Here's the state. The value 6, I found 2. I found 2 10s. This is what I was talking about earlier here, do not repeat. At this point, it said I have 1, 2 10s. This one, it started counting. It counted from here and said, hey, I only found 1. That was where I was saying we needed to take into account if we've already done this. So, how can we keep track of this sort of tally? We can keep a list of what values we've already looked up. We can keep a hash and sort of keep track of it there. Let's say const count hash. So when we get a value in here, before we start looping through everything, we can say, hey, did we already figure this out? And if we did, then we can just skip to the next one. So if count hash already has an entry for value, put it on the right line, then we've already done this, and we can just break and go to the next one. Otherwise, we're going to do all this stuff, and at the very end, we're going to say, hey, count hash value equals count. So we can see this happening. Console log, already did this, count hash value. Let's see if that works. So count 5, count 6. Says count 6, found 2 of them. Count 10, found 2 of them. It's like, hey, I already did this for, what's the last one? 10? Yeah, so it's like, hey, find 10. All right, there's the first one. Hey, I already did this. And I'm telling you, there are 2 of them. So looks like we don't have to worry about the redundancy there. Another example. Hey, count the 5s. There are 2. Yeah, I already told you there are 2. Okay, count the 5s. There are 2. Cool. So that's working. So the last thing I think we need to check, let's get rid of that. That's working pretty well. Is we need to see, does it match exactly whatever this data thing is. It's a bad name. Let's change it to number of instances. Or we'll call it frequency. It's frequency. So at this point, we will say if count strictly equals the frequency, then we can bail out of all of this stuff and we could just return the result from here. I don't really like that because it's sort of, this is already ugly code. It's so long and like hidden in the middle of this, there's going to be this escape hatch. I would prefer if everybody escaped from the end of the function here, all of the different paths. So I'm going to say, let's set the result here, and we are going to break and add a semicolon because we're cool like that. Okay. Here, we're saying, is this cached? If yes, bust out of it. Here, we are initializing our counts. Here, we're making a couple indices to keep track of stuff. We're looping through, finding next values. Then we update our hash. Then we finally check to see if we have a result that we need to. We can break out of this whole loop altogether. So let's run that and then see if we can clean it up again. I see some ways that make it a little bit nicer. Yay, they passed. Let's try the big stuff. See if there are any bottlenecks for performance. Ooh, or maybe just the wrong answer. Well, let's see here. I expected maybe there would be some performance enhancements, but I did not expect it to fail actual values. That's fun. What did we do? What did we do incorrectly? Well, I wish I could see the answer, or the data that failed. Well, it's kind of silly. Here, just unlock. It expected a whole bunch of zeros, but it got what? So this had 1,000 records. What could we have screwed up in here? This is hard to see. The expected output and what my actual output should be, I guess. If this was a basic logic error, I would think that it would be failing on all these other ones too, but I guess it's not. So maybe there's some sort of an edge case here. Let's see, this is the expected output. This is the input. Cool, cool, cool. Doesn't show me what I actually put. or if we can feed this as input. And see the results. Well, how is this? So that's the output. What they expected was, good lord, do I have to diff all this? What's going on? I guess I'm gonna have to like diff this to see what the dealio is. It's not super cool. Oh, what's a good way to do this? PV paste. We're going to paste my actual. Okay. And then this. Is not going to work. I'm going to curl this bad boy and I get a nice little text file. And I'm going to change the crazy ass output into expected txt. Alright. So we're going to say diff. My goodness, I don't remember how to do a diff. There we go, diff actual with expected. There we go. Okay, so a whole bunch of lines the same. Line 43 on the left, I gave it a 0, but they expected a 1. What the hell? And line 33 would be what? I guess it would be the 33rd instance of this. So, let's read from there. Oopsie. Read. That's weird. I must be missing some headers or something in here. Let's just do. What am I doing? Copy that. There we go. Keep it simple. Okay, so I need to find like the 33rd or the 43rd instance of this query. How do I do that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. It's confusing. It is 35. Oh, no, I'm going for 43, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 44. This is really difficult to get any useful feedback I believe they're asking me if there are any 3s left in this guy, and I'm telling them no, but they think there should be. Well, how can we get some info here? Let's say need some sort of feedback. Hmm. Three is the query operation. I'm saying, are there any actual 3s in here? No, I'm saying not are there any 3s in there. I'm saying are there any values who occur only 3 times? So to get something out of here, why don't we ask it to oh, wait. This was an optimization, I think, that we could bail out if we needed to. Alright, I'm getting distracted. Sorry about that. Let me just say, I want some feedback here. So if frequency equals 3, I need to know about what's going on here. Console log, I don't know, 3 count. I just need something here. Okay. It's my debugging output. Yeah, there's a 3, there's a 3, there's a 3. There are several 3s. This isn't helping me. Let's run them. Oh, I don't want to do that. Let's run them all again and see if anything else jumps out at me. Where could I be screwing up? Adding the values is pretty much foolproof. Splicing the values, I could be messing up there if I have the signature incorrect. I don't think that's the case. That's working pretty well. I mean, if it works once, it always works. Another problem is maybe I'm messing up when I'm bailing out. let's see. Now remove, look for the index. Seems fairly straightforward. So check frequency is the most complicated part. This other stuff is just updating the state, updating the state. Ooh, is it? Yeah, that's right. Well, adding a result. There's not really any logic there either. It's all this check frequency. So we know that our hash works. Is it possible that we are counting incorrectly? Let's look at the constraints here. For I in state length, yeah, we need to go through all of them for sure. Grabbing the value, that's easy. Do we have any masked or shadowed variables? I could always screw up. So here, index is I. The next index is from here onward. I hope that's the right state index of, does it tell me? Man, this autocomplete is wicked fast. I feel like, now this is fine, because we already counted them when they were adjacent, and they were fine. So we're saying if the next index is greater than -1, increment our count. Add the next one. And carry on. I don't see any real problems here. We could maybe change this around a little bit to be like if the next index is equal to -1, then we could break out of here. And this can just be truthy. Just run this on the basic code again. Make sure it's working, yay. Update our result there. And return it. Ooh. I just realized this is a trick. It is telling us to modify our data structure, and then it was telling us to check frequency and remove, and the example was pointing toward an array, but that's kind of silly because we actually don't need an array data structure. We want an object so we can just keep track of the tally. And then we don't have to keep looping through some unwieldy array. We just need to adjust the counts of the object. And there's no more looping madness. That's going to fix our performance, and that's going to fix the performance because we'll only need to go through once. As we'll only need to loop through the queries once, then we have our answer. So that'll be O of n, and then the updates, just a constant, so O of 1, I guess. And that will simplify things, and I believe take care of this nonsense. So, back to the drawing board. Where are we? There's our drawing board. So, our queries stuff, a lot of this is the same because we wrote good code and it was modular. We don't have to break apart the whole thing. Our state is actually going to be an object. Instead of pushing, can you see here? Instead of pushing, we are going to add it to our state. So we'll have like the state value, and then we're going to increment that or set it if it hasn't been set yet. Delete will be the opposite of that. We're just going to look and say, hey, if you exist, decrement, if you exist. Tracking that. Then, when we want to check the frequency, we need to look at this. So we're going to look through the keys of our state. Object, keys, state, and I don't know, we'll just say it's for each. We're going to say, well, now we have the count because we can just look at the state and this key. And we can say, does the count equal the frequency? Frequency? If it does, we found our answer. We don't need to like do any weird looping or anything like that. So lesson, I could have stopped and really thought about what the problem was asking and what information we needed to track and what the best data structure for that was, and saved a little bit of heartache. But c'est la vie. Now, let's update this stuff. So, got a lot of stuff to change. That's all right. So, goodness, this is good, bitch. This is not Vim, man. It's a lie. So the state is this. For each query, we're going to say insert here, remove here, check frequency. Look at that. We don't even have to change any of that stuff other than that data. I don't know what the data type right there. That's some good code. So insert is going to be slightly different. Let's give us a little breathing room here. We're going to say const count equals state data or 0, and then we're going to return the state data count plus 1. So it says go grab the existing value if it's there, or give me a 0. And here we're going to return the state, and we're going to increment this. The removal is going to be pretty similar. We're going to say const count well, let's just copy this part. Count equals this. Actually, I could just copy all this stuff. Remove 1. Same sort of dealio. We're going to say go find it in our list. Or 0, I guess is kind of silly. Oh, they never, let's see if it contains the data element. Let's leave this. This is kind of weird, but it's possible we could get a remove that says -1. No, let's not do that. Delete 1 occurrence if present. So let's change this around a little bit. We're going to say if there's a count, return this.
It's 14 hours.
Otherwise, just return the state. Now we could add a ternary to make that a little more readable, but we won't right now. So checking the frequency just got a whole lot easier. All this crazy foolishness. That's always a sign, right? Like if you got just too much random crap in there, something's not right. Let's run this just to make sure our syntax is all good. 0, 0, 0. Okay, that wasn't. Now, how are we going to check the frequency? Our state is now a hash, right? So we're going to say object keys of our state. I don't want to do it for each because, again, I want to be able to bail out of here if I need it. So let's just do keys. And for I equals 0, I less than keys length, I plus plus. We're going to say the count is our state and the current key. Now, if count is equal to frequency, result equals 1, and break. Let's try it. Oh, goodness. Again, they're all correct. Let's run all of them. Should be a little bit faster this time. Oh, it's faster. And with using it. Ooh, ah, crap. So the code is simpler for sure, and it's marginally faster. Still didn't get one though. So this is a step in the right direction though. So I feel like looking through this, there's a way that we need to optimize this, because looping through all of the state could get, or it clearly is, expensive. So how could we keep track of if there are any instances, or if there are any counts, without having to go back and count them up again? Let's see, for each frequency, or for each query, you know, this is fine. We'll come back to this. I do have to do some work though, so this is probably a long video considering nobody's ever gonna watch it, but let's hopefully somebody finds it one day. I'll come back and do this, but as far as just banging out some code, we got all except for 1 working. So I think this was a successful exercise. And let me stop this. See you later.